Hi, I'm Lalit Vasist and you're watching Engineering Made Easy. In this beautiful simulation of fluid dynamics, we will learn various concepts like what is equation of continuity. We will measure the speed and pressure of this fluid at various points. We will also vary the flow rate of this fluid and will add friction to it. We will see it without friction and by adding friction to this fluid. Okay, we will also vary the fluid density and will see how it affects various parameters. We will also learn here how the velocity of the fluid is affected when we change the cross-sectional area of this pipe. So let's see all these concepts by this demonstration. So we will start with the equation of continuity in fluid dynamics. So what we mean by the equation of continuity? It tells us that the product of area of cross section and the velocity is constant for a fluid to flow. It means if we decrease the area, then the velocity will be increased, and if we increase the area, then the velocity will be decreased. You can understand it with the help of a simple practical example. Suppose we have a pipe that has water flowing out of it, and if we press the pipe, then the water will come out from the pipe at higher speed. So we have reduced the area of cross section of the pipe, then its velocity increased. This is nothing but the equation of continuity. It means area into velocity is constant. It is nothing but simply the law of conservation of mass. Okay, for a fluid to flow, it must conserve its mass. So let me show you how it happens. Look at this. Here I have a pipe, okay, and fluid is flowing through it. So let's understand it by changing the shape of this pipe. I will reduce the area at some places, while at other places I will increase its area. You observe the velocity, how it affects. Okay, at this place, let me increase this area, and at this place I am reducing the area. Okay, I have reduced the area at this place. Okay, now you can easily observe that at the place where the area is large, the velocity is small, velocity is less, and at this place where the area of cross section is less, the velocity is high. We can also observe it with the help of this speedometer. You can measure the speed and the direction. You see here it is showing, this arrow is showing the, what is this? This is a vector. It is showing the direction. Is direction of arrow is showing the direction of the fluid and fluid particles, and the magnitude is shown by its length. So it's 0.5 meter per second at the place where the area is large. Let's move it towards smaller area. You can observe it by its magnitude, that its value is 5 meter per second, and the length of this vector, blue vector, showing its magnitude, that it is much higher in comparison to at this place where it is 0.5 meter per second, and here it is 6 meter per second, 6.1 meters per second. So this is the law of continuity, the equation of continuity in fluid dynamics, which says that if I increase the area like this, then its velocity will be reduced, and if I reduce the area, then its velocity will be increased. So the product of area and velocity is always constant in this flow of fluid. This is the law of mass conservation, because the amount of mass that is entering from this end must come out at the other end. Okay, so the mass is conserved. If I have larger area for the fluid to flow, then it must flow at lower speed, so that the law of conservation of mass is followed. Okay, you can more clearly visualize this equation of continuity by this thing that I'm going to show you. Here I'm pressing this button, and you see few dots. You observe its motion, that they are moving at very small speed at this place, and as it passes through this constricted area, that is a smaller area, its velocity is increased. You observe here it is moving at low velocity, very low velocity, and as soon as it passes through it, it moves at fast rate. Okay, so this is nothing but the equation of continuity, that is area into velocity is always constant. Okay, now I will show you one more concept related to the pressure of the fluid. According to Bernoulli's theorem, if there is a horizontal flow of a fluid through a pipe having varying cross-sectional area, then according to this, the pressure is reduced at the places where the speed or the velocity of the fluid is high. So at the place where I have larger area, that is the velocity is low, its pressure should be high, and at the places where the velocity is high, the pressure should be low. So let's measure it. You see that at this place we have a smaller velocity, so the area, so the pressure is 122.579 kilopascal. Okay, pascal is the unit of pressure, so you remember 122.5. Okay, and at this place, as I move at this place, it becomes 101. Okay, it has reduced because the velocity of the fluid is high at this place. So as I'm moving towards the particles having a lower velocity, the pressure is increasing. 110, 113, you see 117, 118, 120, 121, 122, and in this way 124. Okay, and as I move at this place, the pressure reduces. It proves Bernoulli's theorem, according to which, actually Bernoulli's theorem will be discussed in another lecture, where I will dedicate the whole lecture for the Bernoulli's equation. We will learn how it affects the velocity, pressure. It is actually the law of conservation of energy, while the equation of continuity that we have just seen is the law of conservation of mass. So this was mainly dedicated to the law of conservation of mass, that is the continuity equation. In next video lecture, I will show you what is the Bernoulli's equation. Okay, we will see it. So I hope you liked the video, and we can also vary various parameters. Let me change various parameters, and we will measure its speed and pressure at various points by varying the area of the pipe. Let's change the friction. Okay, I will show you the friction, how it affects the motion of the particles of fluid when I add the friction. Okay, let me first reset it, okay, to the normal shape. Now I will add few dots. You see the velocity of these dots. Okay, they are moving very smoothly. Okay, you see here. Now I will add some friction to this. Now see, friction has been added. This is the shape of these dots. You see, it is resisting the motion of the free flow of these particles of fluid. Without friction, its motion was like this. Okay, but when I add friction from this into this, then its shape will be something like this. Observe the motion of these particles, dots. Okay, and we can also change the flow rate from this. Okay, we can increase the flow rate. Okay, its velocity will be increased. We can add the flux meter to it. Flux meter is what? It shows the flow rate in liters per second. Okay, it would be better to change the shape so that you can get better idea of it. Okay, you see, if I observe it, then you can see here that the area here is 0.8 meter square, and the flow rate is 8749 liters per second. Flux is what? Flux is denoted as the flow rate divided by area. You see, liter per second divided by meter square. So how much fluid is flowing through this cross sectional area per second. So this is the flux. You see that it is a 0.8 meter square at this place. Area is low at this place, and its value is flow rate is 8749 liter per second. So you observe the flux at this place here. So here the area is small, so the flux is high. It is 11,103 liters per meter square second. But as I will move at the place where the area is high, then it will be reduced, because here it is nearly 11,000, and here it is what you see. Here it is not 11,000, it is just 1,265 liter per meter square second, because this area is in its denominator. It is, as the area has been increased, so flux has reduced. So I hope you got all these concepts of continuity, and how it affects the motion of the particles of fluid when we change the cross section, and what is its effect on its velocity and on its pressure. So we also observed the motion of the particles in the presence and in the absence of friction. Okay. So hope you liked the video. For more such videos, please don't forget to subscribe my channel Engineering Made Easy. I will upload more such videos in future also. So keep watching, like and share the video if you found it useful and liked it. See you soon in the next video. Till then, bye bye.